time to take a look at two bug zappers. This one I got from a thrift store for $1.99, and this one I bought from Canadian Tire for, I think it was $7.99. And I'm going to see what the differences are, because there is a big difference. One, actually, pretty well, I'm pretty sure, doesn't have a bleed-off resistor for the capacitor, which could lead to a shocking surprise. Now you can take a guess which one, the $1.99 from the thrift or this one. This one runs off of two AAA batteries, and this one runs off of two C cells. So let's give them the test. We'll just show that it works first. Well, that one definitely works. Now let's see. We turn it on, take the finger off, no zap. We know who the loser is on this one. Turn this one on, nice zap. Works fine. Turn this one on, leave it off, watch the birdie, I ain't cheating. No bleed resistor on this one. So I'm going to take this one apart. The schematics will be at that time there. Ditto for this one at that time there. Have removed the batteries from this one. Double check just in case I push that button by accident. This one's nicely constructed, and it's got 5 screws, so I'll take them off. No use you looking at the back of my hand when I unscrew these. There we go. Nice little switch there. And then I'll undo that one. And now I'll zoom in on it. So we can take a look at this close up. Right off the bat. Right there. There's 2 holes. And there's no resistor in there. How lovely. The capacitor here is 223, so 22 nanofarads, rated at 2 kilovolts. Then on the other side, let's see if you can see that. 1000 picofarads at 400 volt rating. That one's the same. This one is 100 picofarads at, I'm having a hard time seeing that. Three kilovolts. Oops. 3 kilovolts. Then we have our transformer. We've got a bunch of diodes, and the circuit diagram will be up in the corner there. And this transistor here, let's see if I can get that lit up. Is either a D or an N 96520AL. And I'll figure out what that one is in a moment. I actually had to take it off out of the board to get a good look at it and then stick it in the tester. It's NPN. So now I can do up the circuit diagram. Well, here's the circuit for the blue bug zapper. This part here is actually straightforward. You've got your battery, LED. They're not putting much current through that LED. 1.8K resistor here. Then, and that's a resistor over here. Then there's the feedback circuit to the BJT. And as I said, I had to put that in the tester to get the pins, and that feeds the primary, so this whole part here just oscillates away. The other side is kind of different. It's not what I've seen on other stuff on the YouTube. Okay, here's your secondary. You've got the 3 kilovolt 100 picofarad capacitor here. You got your diodes, and then of course your large capacitor here. The holes for the resistor that's missing. Your leads coming out for the lower, upper, and this one for the middle. I can't totally figure this thing out. I see how it works half the time. I don't figure out how it works the other half the time. So if you've got comments, add them. I have double checked everything, triple checked it. This capacitor is in parallel with these two capacitors, which is evident right there. Trace capacitor, trace capacitor to the other trace. So somebody else can figure out how that works. On to the next one. Well, this one was harder to get into. After taking the batteries out, it had a ring here. Then they had plastic inserts over top of the screws, which made it very interesting to get into. The small one at this end came out pretty easy. The other two I pretty well had to gouge out. So, and I wasn't going to show that on video because that definitely was not the way to do it. So I've removed the 3 screws. This should just pop open, I hope. Yep. Well, I would say this switch is a bit more beefy than the other switch. And first look at the board. Oh wow, they're even using clips on this one. I kind of think this was probably more than $7.99. Wow. Okay. And I'll now take out that screw. So this one's built with a few more components. I'll have the schematic up there shortly. The big capacitor is 100 nanofarads at 1600 volt rating. Neat that they have all these little connectors for everything. But time to take a deep look at it. So for the black Zapper, 3 volts, light bulb, same circuit. They're using an 820 ohm resistor versus a 1.8K. All I could get off the chip was, or the transistor is 5609. I'm pretty sure it's just another BJT. Wiring was the same. For the secondary, it's a bit different. Now there's a comparison of the two. The components on this one actually look better. These capacitors, well, these ones down here were rated for 400 volts. These were all rated at 2 kilovolt. They were all 220 picofarads. The main one was the main one is 100 nanofarads at 1600 volts. They've got a bleeder resistor. Yeah, amazing. 22 meg. And they've even got a backup bleeder. The switch actually has 2 sets of contacts. The one over here and the one in here, so that when you take your finger off the button, it normally closes, so it's also bleeding through a 1.2 meg resistor. I think something was built with a bit more safety in mind. So there's a circuit. You can go through it to figure out which way all the currents are flowing. Works quite nicely. So I'm going to now have to put these all back together, and I'd definitely say this would cost more than $7.99. Have a good one. There they are side by side. I later realized I'd chopped off the bottom. And the plan is to take either that one or that one and see if I can make an alpha particle detector by setting up enough voltage between them. Hey, that's why I had the last two videos. Have a good day.